Hello students, and welcome to section 7-4, Factoring Polynomials. Example 1. Find the greatest common factor. What is the greatest common factor, or GCF, of the terms of 12x to the fifth plus 8x to the fourth minus 6x to the third? Step 1. Write the prime factorization of the coefficient for each term to determine if there is a greatest common factor other than 1. So when we go about this process, again, looking at the three terms, this is a fifth degree trinomial. We try to go through and looking at the coefficients of 12, 8, and 6, as it describes one instance of 2 is the only common factor of the numbers. And again, the terms 12x to the fifth has a coefficient of 12, 8x to the fourth, 8, and negative 6x to the third, 6. Now, we don't count the negative necessarily. We don't have to necessarily. Because as we discover that the GCF in this case only is 2, looking at the factors of 12 being 2, 2, and 3, this is called the prime factorization, technically. 2 times 2 times 3. The prime factorization of 8 is 2 times 2 times 2, while of 6 is simply 2 times 3. So the greatest common factor between all three factorizations here is simply 2. Step 2. Determine the greatest common factor for the variables of each term. So now, not only we're going to count the coefficient GCF constant of 2, we're going to count the variables. So let's take a look. X to the fifth, x to the fourth, and x to the third. The three instances of x are the only common factors of the terms, so the GCF of the variables is x cubed. And as you can see, similar to when we did the breakdown of the prime factors for 12, 8, and 6, x to the fifth is x times itself 5 times, x to the fourth 4 times, and x to the third 3 times. What happens here usually is that the lowest of the three, or however many terms you have, the lowest degree, that particularly matches up with at least 3 here and at least 3 there. So the GCF must be, as it turns out, x to the third. Overall, the final GCF is as such, or greatest common factor, same thing. So we've got, again, this trinomial, overall 2, as we saw from up above, but also now x to the third. 2x to the third is your GCF, greatest common factor. Example 2, factor out the greatest common factor. Why is it helpful to factor out the GCF from a polynomial? Consider the polynomial negative 12x cubed plus 18x squared minus 27x. Step 1, find the GCF of the terms of the polynomial, if there is one. Because the first term is negative, it is helpful to factor out a negative 1. So we have negative 12x cubed, 18x squared, and negative 27x to take into account. So yes, in this case, you are going to deal with the negative sign. On the last problem, we didn't, because we were only discovering the GCF. We weren't actually doing any official factoring out of the GCF. So it turns out negative 12x cubed can be rewritten as negative 1 times 2 times 2 times 3. Again, notice the negative 1. And then you have at x times x times x. 18x squared, you can see here we've got, 3 times 3 times 2, I would argue, is 18, but they also included a negative 1 and a negative in front of the 2. Why do they do that? Well, we're going to go ahead and assess that even though there is not a negative sign in front of 18, you can multiply a negative times a negative to get that positive. Okay, we are going to use the negative in the same context as kind of what we've seen in the past, or at least in this last term, noting that, well, they are common. Similarly, and then you see the last two terms, x times x, which is x squared. Similarly, except because negative 27 is in fact the coefficient, it being negative, we do negative 1 times positive 3, 3, and another 3. 3 times 3 times 3. Noting what is common, we have got a 3, and a 3, as well as an x, and an x. Again, those are the greatest common factors thus far. And then lastly, negative 1, -1, -1. So that is what's common between all three terms. The greatest common factor, therefore, is -3x. Step 2 is to factor out of each term, factor the GCF, out of each term of the polynomial, so that you have what? -3x. Again, there's the factored version, so to speak. You're dividing it technically, is really what factoring entails. So you're dividing -3x out of -12x cubed. So they give it this way: -12 divided by -3, there it is, 4. X to the third divided by x to the first, if you think about it. Remember, we subtract 3 minus 1 to get 2, so there it is, 4x squared. And so on and so forth. 18x squared divided by -3x is -6x. And -27x divided by -3x is +9. This is the fully factored version of, again, using the GCF as we found to be -3x, such that we're left with those three terms in parentheses. Factoring out the greatest common factor results in a polynomial with smaller coefficients, okay, and or smaller exponents of the variable. This makes it easier to analyze the polynomial or factor it further. In the future, we may take this resulting quadratic trinomial and factor it another step or two. Example 3. Factor a polynomial model. Eleni is in charge of marketing for a travel company. She is designing a brochure that will have 6 photos. The photos can be arranged on the page in a number of ways. So here's the setup. We've got, and I'll show everything here. There are 2 main square photos, here and here, which have a length of x inches on each side. So x by x. Same with this square picture. There are 4 narrower photos that are each 1 by x inches. So this would be 1 and this would be x. And of course there's 4 of those. So if we take a look, what is the total area of the photos? First, find the area of each type of photo. So area equals area of the square photos plus the area of the narrower photos. Let's talk about how each one can be broken up, and I'll show you the rest here in a moment. Let's do that like that. So 2x squared, again, because there's 2 squares, we've got 2 times x by x, or of course x squared. Similarly, and again, because we're talking about rectangles, it's length times width, we do 1x, because again, this is 1 by x, and because there's 4 of them, it's 4 times 1x. Again, 2 square photos, each of an area width by length x squared, inches squared results the same in a similar manner, but of course 1 by x for the narrower ones. So if you take a look, we can see here that you combine the two by adding, such that we've got 2x squared plus 4 times 1x, or 4x, and therefore your total area of the photos is 2x squared plus 4x. Let's continue to part B. Find a rectangular arrangement for the photos. What factoring represents the arrangement? So we can do this with now the factoring. It says try placing the photos in one row. Here's our new arrangement. Okay, so the arrangement has a height of x and it has a width of 2x plus 4. Remember, this was x by x and then 1, 2, 3, 4 as its, let's just say, width dimension. Each one of which, of course, is 1 by x, but we only want this essentially taken into account. So again, there's x plus x, that's 2x plus 1, 2, 3, 4. So 2x plus 4 in total on this total kind of, call it width, I guess, if this then would be your height. And they say that, width versus height. The factoring that represents the arrangement is x by 2x plus 4. Part C says factor out the GCF from the polynomial. What does the GCF represent in this situation? So I'm going to go back to part A for the moment and look at 2x squared plus 4x. So for our purposes, 2x squared and 4x does in fact have a GCF of 2x, so you can rewrite the expression as 2x times the quantity x plus 2, which as an arrangement, geometrically speaking, takes shape like so. So the arrangement has 1, 2, so 2x on this dimension, this height, and then x, and then 1, 2, so x plus 2. So 2x by x plus 2. And that, folks, that is the factored form that this picture helps us understand from part A. Just rearranging things, you can see that taking shape accordingly. So the factored form, of course, is just that. The GCF represents the height of one possible arrangement of the photos. Part D, which of these two arrangements is a more practical use of space on a page of the brochure? So for this, I would argue, and I would agree, as they say, the arrangement based on the GCF is more practical because the arrangement with the photos in one line will be too wide for a page. This right here, certainly I would argue is too wide on a page, then maybe this would essentially take shape as. Okay. So one thing I want you to do for tonight, on top of doing the homework, of course, is I want you to take a look at maybe one of these try-it problems, the last try-it in particular. There's always try-its that you can go ahead and take a look at on your own, of course, example 2, of course, as well as example 1. But before you do your homework tonight, I think this particular try-it would be worthwhile practicing. So please take a look at that and, of course, do your homework for tonight.